I hope the recording is started. Just check it. And here if you want to find out this L inverse, for example, I'm going to take only one function or this term. Okay, you may realize that how we are going to apply. For this term, suppose I am going to consider, okay, this term I am going to consider. So this term means here, consider this L inverse of e raised to the power minus as f of s means inverse of that. Before that, if L of f of t is f of s, then L inverse of f of s is f of t. This is one result, and the second one is if L of f of t minus a h of t minus a is e raised to the power as f of s, then L inverse of e raised to the power as f of s is. So if the exponential function is, if it is in the product of some functions, namely it is our remaining all those things f of s except this is f of s called, then first we have to write this h of t minus a. Then this L inverse of f of s, only here we are having that L inverse of f of s. So this L inverse of f of s is denoted as f of t, but that t should be replaced by t minus a into this h of t minus a. So overall result is f of t minus a into h of t minus a. Is it clear? Okay, the results. Here we are having this results. Students, is it clear?
Yes, sir.
Okay, yes, so sir. This ideology only here we are following. Okay, so just consider this part. Just consider this part. L inverse of minus 1 by 4. So this minus 1 by 4 I may take outside of this. Minus 1 by 4 L inverse of this e raised to the power minus 3s 1 divided by s square plus 4, 1 divided by this s square plus 4. So here actually if I want to apply the sin t to get, I just try to multiply and divided these things, these two, right? Is it clear from this term?
Yes, sir.
So this can be written as, already here it is minus 1 by 4, here 1 by 2, so minus 1 by 8 L e raised to the power minus 3s is still fixed. Okay, so this 2 L inverse of 2 divided by s square plus 4 is what? Sin 2t, right?
Yes, sir. Yes, sir. Yes.
For this e raised to the power minus 3s, just apply this result. L inverse of e power minus as into f of s means first this heaviside functions are this unit step function we have to write. Then with that, the f of t is sin 2t, then t should replaced by the t minus a. So that sin of 2 times of this 2 minus t minus 2. So that's our result. So that's why here for this term minus 1 by 4, this 1 by 2, h of t minus 3, sin of 2 of t minus 3 is given. Is it clear?
Yes, sir.
Okay, but now yesterday the last class, okay, this problem we discussed actually. So here consider this L inverse of this part. Okay, first I am taking this 10 to the power minus 5, 10 to the power minus 5, 1 by s e raised to the power minus 2s. Okay, so this is L inverse, under L inverse. So the resultant is 10 to the power minus 5 is constant. E raised to the power minus 2s means it is h of t minus 2. Then this L inverse of 1 by s is, what is L inverse of 1 by s? It is 1 only, right? Am I right?
Yes, sir.
So there is no concept to replace the t by t minus 2. Okay, since it is a constant term. So for this term, L inverse of 1 by s e raised to the power minus 2s is only h of t minus 2. If we multiply it here, it is 10 to the power minus 5, 10 to the power minus 5. The first term it is okay. Then the second term, 10 to the power 5 minus 5 is common. 10 to the power minus 5. L inverse of e raised to the power minus 2s. Then 1 upon this s plus 4. What is the answer? 10 to the power minus 5. For this L inverse of 2s is h of t minus 2. T minus 2. For this e raised to the power minus 4t. Am I right? L inverse of 1 divided by s plus 4.
Yes, sir.
E raised to the power
Minus 4t
minus
into
4.
1.
E raised to the power minus 4. E raised to the power minus 40. That t should be replaced by t minus 2, right? So that is here it is given. Here it is given. Okay. And then third term, I think these are all same, right? This is 2s form. Here it is 3s. Here 2s form. Here it is 3s. Okay. So it is under 2s, 2s. Now the same thing for 3 also, right? The third one, 10 to the power minus 5 L inverse of e raised to the power minus 3s divided by s means it is s means divided by s under exponential functions, so that it is 10 to the power minus 5 e, here it is 1 by s, so 1 into h of t minus 3, h of t minus 3, t minus 3. The fourth one, 10 to the power minus 5 L inverse of e raised to the power minus 3s 1 divided by s plus 4, s plus 4, which is that 10 to the power minus 5 e raised to the power minus 3s means h of t minus 3, and it is e raised to the power minus 4t, so t will be replaced by this 3. So that's the resultant here we are having. Okay, one by one here. So these many times they are written. Okay, just if you are applying the things, okay, applying the things, immediately you may get the answers. Okay, this is for even our understanding purpose I wrote. If you know the results, with this you can directly write that this results. Okay, this results E output. This is our Q of t. Is it clear? And if you are compared the input voltage and the output voltage and that electric circuit, when we are having this on and off conditions in this part, if you are giving the things with this, when you are going to switch on this one, okay, 10 voltage, it is going to pass this 2,50,000 ohm, okay, into 10 to the power minus 6 Faraday. These are all the inputs. With this, the output will be, we are going to compute E output voltage. Here we have to compute, so that this E of t, okay, so here it is based on that functions, it is at t, when t equals to 2, it is 10 we are having, and the t equals to 3, between here we are having, so 10 times of this t minus 20 minus 3, just using the Kirchhoff's voltage law. Since it is a first order differential equations, we able to solve in easy manner. And comparing the analysis of the results, until this 2 is no power, okay, and between this 2 and 3, within this 1 seconds of that time, it reaches 10 voltage. It reaches 10 voltage. Then what will be the output if we are giving 10 voltage current to that network, that electric circuit? So what will be the output of that? Output voltage. Okay, it is between here, it is up to the 2 is there is no answer. Okay, up to the, this is getting from here up to the t minus 2. Okay, t minus 2, there is no point. Then it reaches the height up to this number 10, then it is suddenly it is fall down. Suddenly it's fall down. This is the analysis. In exam, you no need to give this graph and all, but this problem you have to solve. Okay, next problem. Next problem the similar way. Okay, consider the differential equations. Here the same on-off conditions. Here the ohm is, it is 2.5 into 10 to the power 5, 10 to the power 5, 10 to the power minus 6, 10 voltage. Okay, I of 0 and Q of 0 is 0, which means that I derivative I of 0 and I derivative of 0. Okay, that's a concept. Okay, and it is everything is defined. This is in the form of I of t and this is in the form of Q of t. So we have to consider the variable, it is same. Even this problem also, here it is initially I of t, then it is Q of t. So this I of t is given it as write it as Q derivative of t, derivative of the current, right? This should be written in this way. All the things we are going to convert in the form of Q. The same way here also, here we are going to convert this I of t is Q derivative of t by Kirchhoff law using these conditions. Okay, E of t we should calculate. Okay, E of t, the voltage output here we are computing at this point E. Okay, then what is the condition? Actually, this is given by this 2 to 3, it reaches 10, right? Am I right?
Yes.
So right hand side function, the heavy side function is denoted by E of t is written by the heavy side function of 10 times of h of t minus 2 minus h of t minus 3. Am I right?
Yes.
Yes, sir.
Okay, the same like our previous problem we are having. Okay, so we just write and then solving this differential equations. See this L of E of S from the previous problem. If you are taken, this is the conditions e power minus 2s by s and e power minus 3s by s by using the condition. Now this relations, it can be written by the integrable equations, and this integral equations only we solved in our problem like in your things. 1 minute. This integral equations problems also we solved, right? This kind of interval equations. Am I right? Solving first order differential equations. If you are applying the
Yes,
Laplace
yes.
transform from 0 to t y dt means it is the relations. If you are going to apply, it is 1 by s f of s. The same kind of results here we are going to apply using the integrable equations, because here we cannot solve this. We cannot simply solve this. Consider the questions here. It is Q of t is there 2.5 into 10 to the power I of t plus 10 to the power 6 Q of t. The same thing. So what will be the Q of t? Q of t is will be calculated by 0 to t I of tau t tau plus Q of 0, the initial conditions. Since this Q of 0 is 0, Q of 0 is 0, then this will be remains it as 0 to t I of tau d tau, I of tau d tau. So I of t and 0 to t I of tau means it is 1 by s I of s. Is it clear? This one.
Yes, sir.
So this results Laplace transform of 0 to t f of tau d tau. This is nothing but 1 by s f of s. Using this results, we may use this as I of s. 1 by s into I of s. Now this E of t, which is already from that heavy side function, 10 times of that. 10 times of h of t minus 2 minus h of t minus 3 we are having. So Laplace of this 10 we may take outside as a constant. This means L of t h of t minus 2 means e raised to the power minus 2s. Remaining it is L of 1. E raised to the power minus 3s, it is L of 1, which is present. So 10 into e raised to the power minus 2s by s minus 3s by s. So this is your right hand side. This is your right hand side. This E of t. This is your E of t. Okay. So with this, we are solving this. The left hand side, it is very simple. IFS, collecting the IFS separately. So it is 2.5 into 10 to the power 5, and then this 10 to the power 6. If we are having that numbers, we are going to have this partial fractions idea divided by this 1 divided by it is s plus 4, then taking the L inverse for this part. Tell me the L inverse for this. L inverse of this first term 4 into 10 to the power minus 5. So I may take it as 4 into 10 to the power 5 minus 5 as constant. Then it is e raised to the power minus 2s 1 divided by s plus 4. It becomes try this portion and this portions or this one. Tell me this. Answer for this? Yeah, try at least. Definitely on 10 mark you are going to get. What is the result? L inverse of e power minus as into f of s means first we should write h of t minus a, right?
Yes, sir.
Remaining this L inverse of f of s. So f of t we are having, but this t should be replaced by t minus
T
a.
minus A.
T minus a. So you simply using this results. So we are having this. It is e h of t minus 2. Am I right? Then e
Yes,
raised to
sir.
the power minus 4 times of
Minus 4 T.
t minus 2, right? So that's the result you
Yes,
are
sir.
having. Okay, how we are writing? First we should know. Okay, minus 4 times 10 to the power minus 5, 10 to the power minus 5, L inverse of e raised to the power minus 3s, e raised to the power minus 3s, 1 divided by s plus 4. The same way, minus 4 into 10 to the power minus 5, e raised to the power minus 4 times of t minus 3, t minus 3 into h of t minus 3. Is it clear?
Yes, sir.
The same results we are getting. Okay, just using these results. Okay, that's the relations of inverse Laplace transforms. Okay, now the next functions, it is called unit impulses, either or the Dirac delta functions. Dirac delta functions. Actually, these functions, look at this graph. Look at this graph of these functions. Okay, so this graph until this zero, until this zero. Okay, my function has the value, it is 0. Okay, then it is 0 less than t less than epsilon. My function should have the impulse, it reaches the height 1 by epsilon. Once again, hello. Yes, sir. Okay, it reaches 1 by epsilon. Okay, it reaches 1 by epsilon. So that if you are finding the area between this, just finding this area, what is that? Area of this rectangle. Students,
1 by 2.
so area means the distance. What is the base? That is epsilon minus 0. And what will be the height? 1 by
1
epsilon
by
minus.
epsilon.
So what is the area? 1. So that's why here wherever you are having this, you are raising this interval, and all. Okay, this raising in the interval here, it maintain the things. Okay, so here that's why it is called unit impulse. Unit impulse, it is founded by the physicist, namely it is called Dirac. That's why, and the notation it is given by the Greek letter, it is delta. Okay, that's why it is called Dirac delta functions. So delta of t minus a, here we are going to assign r this t minus a, delta a of t minus a. So this is the notations, and this Dirac delta functions. Okay, the resultant may be involved with this Heaviside functions also. Okay, Heaviside functions also. Yeah, look at some problems we may discuss. Okay, this is the graph of that delta of epsilon at the point. Here it is, we are having it is delta epsilon of t minus a. Actually here it is a is 0. Here it is a is 0. The graph of the function is delta epsilon of t only. So t only means 1 by epsilon of the height will be, and it is the given functions delta t can be written as delta of t minus a minus delta of t minus a epsilon. Delta of t minus a epsilon. So the Dirac delta functions, it definitely happens in all your physical problems. Okay, suppose I am going to switch on a fan or a refrigerator or some AC or something, I am going to do that one. or if I'm going by a bicycle, okay, bicycle, if I'm going to that, a sudden impact if it is happened. Okay, that impact, how to measure it? We don't know. A small amount of force it is happened in our system, regular system, whatever the process we are doing it, okay, a small amount of disturbance or some the uncertainty it is happened in our system, it may be called as the name of impulse. So we are going to define under this some period of time interval, maybe between this 0 and epsilon, 0 and epsilon. So whenever it is raised, okay, and at this point, okay, at to that epsilon it is happened, this impulse, it impulses may be reached the height, okay. So based on that, here we are going to calculate, based on that, here we are going to calculate. And what is the Laplace transform of delta epsilon of this t minus a, or this Laplace transform of delta of t minus a, okay, t minus a. So by Laplace transform definitions, what is that? What is that? By Laplace transform definitions, we may have 0 to infinity e raised to the power st and delta of epsilon of t minus a into dt. But the 0 to t here, if you are going to have until this 0 is 0, right? Remaining is t to epsilon only, here we are going to compute. Am I right? Sir, is it clear? Then how can we write this delta epsilon of t minus a? This delta of t minus epsilon a is, we may use this, we can write or this function in terms of, this is my delta epsilon of t minus a, this is the function. By using or writing this piecewise function in terms of suppose this is a, okay, suppose this is the point a, this is the point a, then h of t minus a minus h of t minus a minus epsilon. Am I right?
Yes, sir.
Okay, this delta of t minus a epsilon, this delta of t minus a epsilon, okay, can be written as without this using this function, but just using the Laplace definition and Heaviside functions, we know that 1 by epsilon of h of t minus a minus h of t minus a minus epsilon. If you are having, then 1 by epsilon will be the common, remaining L inverse of, sorry, this Laplace transform of h of t minus a is what? E raised to the power minus as into 1 by s. Am I right?
Yes, sir.
Laplace of h of t minus a. And you may think that h of t minus a means maybe the constant here, it is 1 is there. So you are not going to avoid or miss anything. Remaining it is L of 1. So that e raised to the power minus as 1 divided by s. Okay, then for this is minus of a plus epsilon, can be written as, right? So that e raised to the power minus of, okay, here it is a plus epsilon into s into Laplace of 1 is there, so that 1 by s. So with this proof, we may have this delta of x minus epsilon is, here it is, e power minus as 1 minus e power minus epsilon s divided by epsilon s, and taking the limit 10 to, when it's a right hand side limit, if you're calculating, the resultant will be, it is e power minus as only. So the important one, Laplace transform of delta epsilon of t minus a is nothing but e raised to the power minus as alone. Suppose here a is 0. So Laplace transform of delta epsilon of t, maybe epsilon is not given or given. Okay, this is e raised to the power minus 0 into s. This will be 1. So Laplace transform of delta of t is 1. And L inverse results, we have that L inverse of e raised to the power minus as. Simply it is delta of t minus a. Okay. So L inverse of 1, if you are going to find hereafter, you may use 1 by S or delta of t. Okay. Is it clear? Students?
Yes, sir.
Okay. Next, filtering property. Let A is positive. The point is positive, greater than 0. And f is an integrable function and continuous at this point A. Then 0 to infinity f of t delta of t minus A is always it is f of A. 0 to infinity f of t delta of t minus A dt can be, if you are integrated these functions along with this unit step unit impulse functions at the point A from 0 to infinity, if you are evaluated, then this will be f of A. Okay.
Yes, sir.
Now problem using solving ordinary differential equations. This y double dash plus 2y dash plus 2y equals to delta of t minus 3. Okay, so now we are familiarized with this, right? Solving ODE. Okay, I'm going to solve this one. Okay, plus L of y equals to L of delta of t minus 3. Okay, give me the answer here. It is s square ys minus s into y0 minus y derivative 0 plus 2 times of s into ys minus y of 0 plus 2 times of y of s. Is it clear? This one?
Yes, sir.
Okay, now this L of t and delta of t minus 3 is e raised to the power minus 3s only, right? Using this function. Delta of t minus 3 means e raised to the power minus 3s alone. Okay, now substitute the initial conditions. Since y of 0 is 0 and y derivative of 0 is 0, so there is no term here. It is vanished. Here it is vanished. This term is vanished. So the remaining term only I am going to consider. Just collect the y of s square, then it is plus 2s plus 2 plus 2. Remaining all these terms are 0. Remaining it is e raised to the power 3s. Okay, sir. So what is my y of s? Which is e raised to the power 3s 1 divided by s square 2s plus 2. Okay.
Yes, sir.
Yes.
So consider while you are computing this inverse Laplace transform for this product of these functions exponential things, keep this e power x separately. At the end we are going to have, okay, what is e power x formula? Can you tell me? Which is 1 plus x plus like that it goes on, right?
Yes, sir.
It has infinitely many terms, so we cannot apply the partial fractions or something here. Okay, if we are going to apply partial fractions or convolutions for this part, we just keep aside this e power minus s, computing, consider these portions. For that you are going to have these partial fractions or convolutions. Then later we are going to multiply this e power minus s. After computing this a, b and all. The same it is applicable here also. See, in this term, here if you are computing that, this e power minus s we are not bother about, right? In the last class also we considered this e power minus 3s we are not going to take. It is in the product form, right? We are just keeping it is outside of that, just computing the remaining of these things. With that whatever we computed, then later we are going to multiply it here. Okay, please remember that the same ideology here. Okay, what about the L inverse of 1 divided by s square plus 2as plus 2? Do you have any idea? This s square plus 2s plus 2 can be written as s plus 1 whole square. So s square plus 2s plus 1 plus 1 square. Am I right?
Yes, sir.
So no need
Yes.
here to apply the partial fractions. Here easily we can solve. So y of s is e raised to the power minus 3s. It is 1 divided by s plus 1 whole square plus 1 square. With that, if you are applying L inverse of this y of s is L inverse of e raised to the power minus 3s 1 divided by s plus 1 whole square plus 1 square. So we are not going to further consider this. This is just it is h of t minus 3. So what about this L inverse of this 1 by s plus 1 plus 1 square? Here only constant is there. Shall I take this as e raised to the power minus t? Remaining L inverse of 1 divided by s square plus y square is it is sine t.
Yes, sir.
Can we take this as, and t will be replaced by this t minus 3, e raised to the power of t minus 3 into sine of t minus 3 into h of t minus 3, and this will be the resultant, and this is my y of t. Just check the answer. Yeah, they are giving this one only. Y of t is e raised to the power minus t minus 3, and this is sine of t minus 3, and this is your h of t minus 3. Is it clear?
Yes, sir.
Yeah, in
Sir,
this way,
can you explain that last step, sir?
this part, okay, shall we write
Sir.
one more time this one separately?
Yes, sir.
Yeah, what we are having, this is right, 1 divided by s square plus 2s plus 1. This can be written as L inverse of e raised to the power minus 3s. Partial fractions technique you may apply, but without applying we can simply solve this. That's why I am doing this. Okay. This is in the form of L inverse of e raised to the power minus as f of s, right? So I'm going to take it as f of t minus a into h of t minus a. This formula I have to do it. Is it clear?
Yes, sir.
Okay. Now, what is L inverse of these things? 1 divided by s plus 1 whole square. S plus 1 whole square plus 1 square. வர முடியுமா அப்படி முன்னாடி இல்ல அந்த தேவையில்லை Sir, what is L inverse of 1 divided by s plus 1 whole square plus 1 square? First, I am taking this minus 1 out, right? For this e power minus 3s, h of t minus 3. Remaining it is L inverse of 1 divided by L plus 1 whole square plus 1 square. Is it clear?
Yes, sir.
Okay, these things can be written as e raised to the power minus t first. This is can be written as e raised to the power minus t first, remaining L inverse of 1 divided by s square plus 1 square into h of t minus 3. Now this can be written as e raised to the power minus t, and this is sine t. Sine t. The process is not over because we want to replace this t as t minus 3. Okay, because of the t minus a we have to write.
Yes, sir.
Okay, now is it clear?
Yes, sir.
Student?
Understood, sir.
Yeah, fine. So e raised to the power minus of t minus 3 sine of t minus 3 and h of t minus 3. See, the problem, if you are look at that, suppose find Laplace transform of e raised to the power minus of t minus 3 sine of t minus 3 h of t minus 3, then what you are going to do that? This is the answer you have to get, right? So from all these things, this 3 I should take out, then remaining it is e raised to the power minus 3s, then Laplace transform of e raised to the power minus t, sin t will be there. Sin t will be there. With that, e raised to the power minus 3s. This is extra problem, pa. These are all extra from your content. Okay, this is also extra. Your problem is already it is over here itself. Here itself it is over, or here itself it is over. Here we are discussing more than that. Okay, e power minus 3s if you are writing, then LLS of e power minus t means sin t means 1 divided by this s square plus 1 square, but this s should be replaced by s plus 1, so that e raised to the power minus 3a divided by s plus 1 whole square plus 1 square. Is it clear?
Yes, sir.
Yeah, for this we are computing L inverse. That's why the result here we are having. Okay, can you understand the forward and backward method? It is L inverse, L transforms. This is L in ILT transforms. Okay,
Yes, sir.
the same f of t only here we are getting. Okay, then afterwards, yeah, circuit type problem. A circuit type problem. Okay, consider this circuit. Consider this circuit here in this network structure. In this network structure, suppose in the current, the circuit of this figure 3.33, the current and charge on the capacitor are 0. The current and the charge on the capacitor are 0 at time t 0, right? Initial time. We want to determine the output voltage. We want to determine the output voltage response to a transient modeled by this delta of t. This delta of t. So the output voltage is Q of t over C. So we will determine by this Q of t. Okay, output voltage, we want to determine this Q of t. So with this figure, we are going to frame this by Kirchhoff law, Kirchhoff voltage law. This is LRC circuit. Okay, LRC circuit. Okay, there is an inductance and your resistance and the capacitance we are having. So it's forming a second order differential equations. It's forming a second order differential equations. Li dash plus Ri plus 1 by Cq I dash. So here it is I format. Here it is I format, but this is Q format. Okay, and this I dash is L is 1. L is denoted as 1, and this R is 10. And your capacitance, this 1 by C is 1 divided by this 0.01. So if you are multiplied by 100 and 100, so it is 100. Your 1 by C is now it is 100. 1 by C is 100. So 100 times it is Q, which is equals to delta of T, determined by the transient model. It is delta of T only. Delta of T only. So with this, if you are solving the problem, then what is your delta of t? Okay, so where the initial conditions, the current and charge are here, it is 0. So q of 0 and q derivative of 0 is also 0. This is the given ODE. Governing equation is this one, or this one, or this one. Applying the Laplace transform on both sides of this q double dash plus L 10 times of this Laplace of q dash plus 100 times of Laplace of q, which is equals to Laplace transform of delta of t. So this is equals to q double dash means it is s square q of s, square q of s. Maybe the biggest letter you may write. Okay, maybe the biggest letter, it is s square q of s minus s into q of 0, maybe small one, minus q derivative of 0 plus 10 times of this s into q of s, into q of s minus q of 0, this 100 times, it is q of s, which is 1. Laplace transform of delta of t is 1. Is it clear?
Yes, sir.
Okay, now it is here s into q of s. Solve this problem. Since these two are 0, this vanish, and this vanish. So just collecting the q of s, so which is s square, then 10 times s plus 100 times equals to 1. Okay, so q of s will be 1 upon this s square plus 10s plus 100. So can we write the factor manner? So 100 I should get, and remaining this multiplication is 10. Is that any possibility? 10 times of 10 only 100, right? So no possibility. Maybe the complex roots here we are having, right? So then this can be written as 1 divided by s plus 5 whole square, suppose I am writing. Okay. S plus 5 whole square means what will be the answer?
Plus 75.
S plus 5 whole square means s square plus 10s plus 25. So it is 75. Here we are having that. Okay, plus 75 here we are having that. So this can be written as 1 divided by this s plus 5 whole square plus root 75 whole square without loss of the meaning. Okay, now applying the inverse Laplace transforms. Applying the inverse Laplace transforms. The problem is anyway solved. Okay, for your understanding here I am also doing one time. So L inverse of 1 divided by s plus 5 whole square plus root 75 whole square. So this means that if I want to take this s to the power 5, okay, so root 75 and root 75 I have to multiply and divide it. Am I right?
Yes, sir.
Okay, this should multiply and divide it. Now it is this e raised to the power minus 5t, remaining it is L inverse of root 75 upon this s square plus root 75 whole square. So here it is 1 divided by root 75 is there. So 1 divided by root 75 e raised to the power minus 5t. Then this will be sine root 75 times t. Is it clear?
Yes, sir.
So here we are not written in the form of h of t minus 0, because h of it is defined at a delta of t. Delta of t minus a means all this t should be replaced by t minus a. Okay.
Yes, sir.
Okay, so this is the thing we got it. Okay, this is the result. So the output voltage here we are computed by 1 by c q of t, so which means that 100 times it is. So we are multiplied by this 100. That's the case. So E output voltage, the signal is also given. So with this, the problem is over. And I try to give some problem. You may try in this using this delta function. Do you have that tutorial sheets? We are having these tutorials, right? Model 3 tutorial first to 4. Yeah. See, f of t by using Heaviside functions, some condition it is 1 is given, and then it is 12 up to that 4 second order differential equations. Here it is t more than of that t, it is greater than 0, and then here it is minus 2. Okay, concept wise it is no meaning. Okay, but here it is multiplied by some function, it is minus 2. Okay, that's in this manner they are adding some extra points, and this f of t is defined by it is until that it is maybe 0, up to that 0 they multiplied by this t and t plus 2. Okay, and it is nothing but Dirac delta functions. Is it clear? Sum of two Dirac delta functions. Okay, shall I solve this problem if you are interested, students?
Yes, sir.
Yes, sir.
Yeah, because
Yes,
you
sir.
have these functions. Okay, can you read that problem if you have that, since it is a PDF file? So solve y double dash plus 5y dash plus 6y plus 5y dash plus 6y which is equals to 3 times 4 times 2 and 5. 3 times minus 4, right? Minus 4 times t minus 5. Y at 0, y at 0, y derivative 0 are 0. This is given. Okay, sir, how to solve this problem? So taking the Laplace transforms on both sides, right? So this one L of y double dash solutions for this L of y double dash plus 5 times L of y dash plus 6 times L of y, which is equals to 3 times the Laplace of delta of t minus 2 minus 4 times Laplace of delta of t minus 5. Is it clear?
Yes, sir.
This can be written as s square y of s minus s into y0 minus y derivative 0 plus 5 times of s into y of s minus y at 0 plus 6 times of y of s. So this is my entire things my left hand side, whereas the right hand side 3 times of Laplace transform of t delta of t minus a is e raised to the power minus 2s, right? Again come back this formula, just go through that. E raised to the power delta of t minus a means e power minus as alone. The same thing for unit step function means divided by 1 s is there, right? Is it clear?
Yes, sir.
Okay, this is e raised to the power minus 2s and this is 4 times e raised to the power 5s. So supplying these conditions here, it is y of s s square plus 5s 5s plus 6 equals to 3 into e raised to the power minus 2s minus 4 into e raised to the power minus 5s. Then this is y of s. This can be written as s plus 2 or s minus 2 s minus 3, right? Am I right? S plus 2 into s plus 3, right? This term. Sir, is it clear?
Yes, sir.
So here this term, yeah, I'm going to get the partial fractions. Okay, so multiplied by 6. Okay, when you are adding it should be 5. So s square plus 5s plus 6. Okay, now with this, so here we are not going to touch this part because it is exponential term. Just computing the partial fraction of these two things, right? So what about this 1 divided by s plus 2 into s plus 3? Can you tell me the a and b value? 1 equals to a into s plus 3 plus b into s plus 2. So a is, when s is minus 2, a is minus 1. Okay, b is when s is minus 3, sorry, when s is minus 2, a is positive 1. When s is minus 3, b is minus 1. So the resultant will be, it is 1 divided by s plus 2 and minus 1 divided by s plus 3. So this y of s is nothing but 3 times of e raised to the power minus 2s minus 4 times of e raised to the power minus 5s into this 1 divided by s plus 2 minus 1 divided by this s plus 3. Is it clear?
Yes, sir.
So which means that here you are having 4 terms. So this term should multiply this and this, as well as this term should have multiplications with this and this. Okay, so 4 terms in your solutions you are going to have. So L inverse of y of s, applying L inverse, so we are going to get y of t. The first one 3 times, it is constant. L inverse of e power minus 2s into 1 divided by s plus 2. So what will be the answer? Which is for e power minus 2s h of t minus 2. Am I right, students?
Yes, sir.
Okay, h of t minus 2. H of t minus 2. First, I just consider these three terms. Okay, this term, this term. So this L inverse of this e power minus 2s and this term. Okay, so h of t minus 2. And here L inverse of 1 divided by s plus 2 is e power minus 2t. Is it clear?
Yes, sir.
Okay, so here we are going to write, e raised to the power minus 2, then the 2t will be replaced by t minus 2. This is h of t minus 2. Then this term, this e power minus 2s will be a member of this term also. So now I am going to consider this form. So this will be minus 3 times e raised to the power minus e raised to the power minus 3 times s, so that t will be replaced by t minus 2 h of t minus 3. And this is over like that. The last term, so it is minus 4 times of this 1 divided by s plus 2. Here it is minus 5 means h of t minus 5. First I will write this one. Then this is e raised to the power minus 2t. Then the 2 will be replaced by t minus 5. Like that, it is minus into minus, positive, plus 4 times of this is minus 5s. So h of t minus 5 e raised to the power minus 3t, so that t will be replaced by t minus 5. So in this way we can write these things. Okay.
Yes, sir.
Okay, so in this way we can solve. And in other way, some functions here they are adding with only this delta functions. Okay, in some cases one term will be the ordinary derivative term or the exponential term. One term may be delta function or heaviside functions, or one will be the delta and one will be the heaviside. Like that, the combinations also there. So you have to practice the things. If it is a piecewise things, means from this how to write the heaviside function, or from this directly if it is given how to solve this one, that you have to practice it. Okay.
Yes, sir.
Okay, ma. So with this I will stop because already time is 11:40. So remaining the things what we are having in our syllabus is, if you are checking, only one topic is pending. Okay, just check this one. Just check it. Okay, just check it. Don't consider we are not covered. So already this Fourier series is over, right? Are we discussed or not? Not.
No, sir.
No. Okay. Then this module itself, only one topic is pending. It is very simple. It takes around 20 minutes, and here it is non-homogeneous system, just the product system of equations. Okay, and then this is the second round. Okay, Pahan, for you we need that remaining 4 hours. Okay.
Okay, sir.
Okay, Pa. Thank you. This material immediately I will upload. You practice your side. Okay.
Yes,
Sir,
sir.
Yes.
Yes, boys.
sir, for the tutorial sheets, can you give the final answer alone like you did for module 2
No,
tutorial
I'm
sheet?
not getting your point, Pa. Say loudly.
Sir, for the tutorial sheet questions, can you give the final answer alone so we can cross check?
Okay, possible I try to give, Pa. Okay, because that is you have to solve that and then you have to share the things. If it is anything wrong, then I will give you. Okay, if any one of you or group of people, at least 2 to 3 members, you shared your file with me. If it is anything wrong, I will mention that. Otherwise, if it is fine, then you may follow these things. Okay, that way I will give you.
Yes, sir.
Okay, sir.
Okay, ma. So here I will upload the material in your module number 4. Okay, the heaviside functions. Okay, I'm going to replace it. Okay, so it is your recent one, heaviside function D1. Whether we are having all the things. Yeah, until this end we are having that. Yeah, fine, pa. Okay, the material is shared. Thank you to all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Please attend all your rest of the classes. Okay, don't skip it.